Hello, I've just received this package. It's an item I bought on eBay, and it was described as a Grundig radio suitable for restoration. So it immediately took my fancy, as I just think I might be able to do something with this. So let's open it up and have a look. So I've unpacked the radio, and here we are in its full glory. And it's a Grundig valve radio from around 1960, I think. And the model, as we can see on the front, is a 2066. And it was one of these radios that was quite high in specification, in that not only did it include FM or VHF, which we can see there along the bottom scale, but also quite comprehensive tone controls, two extra what look like bass controls over on the left hand side, two treble controls on the right, and then up above we've got switches here for switching in various tone filters. So overall, quite an interesting piece of kit. And while it does show signs of wear and tear, which is only to be expected for a radio of this vintage, I think it shows some promise in terms of what being able to do. So we'll just go around the back and have a look and see how it looks inside. So here we are now around the back, and as you can see, there's a fair amount of, what would you say, discoloration around the metal chassis. Loads of dust, so there's going to be plenty of sweeping up and cleaning up involved, but at least we can see that all the valves are there. The seller did say that it was blowing fuses, and we can see this is a recently replaced fuse which is also blown. So I'm only hoping that it's not a case that the transformer is faulty, because that could cause problems. But anyway, other than that, all the bits seem to be there. It is going to need a fair bit of cleaning up though before we even start working on it. But I think this is going to work out reasonably well. I can see there's a resistor on top of the output transformer that's been replaced, so that's going to have to be checked to see, first of all, that it's the correct part, and all the valves are in place, which is good. So the next thing is to start by taking the chassis out, inspecting it, doing a bit of cleanup, and then follow a procedure that will check that, first of all, the transformer is in order, and that the power is coming to the HT side of the radio, and after that we shall take it from there. I've taken the chassis out of the cabinet at this stage, so let's go in and have a closer look at what we have here. So you can see from the front here where it says, if my camera will focus. By the way, I'm just using an iPhone for this, so sorry about the poor quality. Made in West Germany, it has printed on the left hand side, and as we go along you'll see that all the text here is in German. So this radio was obviously made for the home German market. So we have our volume control, the Lautstärke on the left, and as we go along we've got the tone controls as before, and the piano key buttons. I see the first one there, the off switch, the Aus switch, is a little bit lopsided, so that's going to need some attention. Then we've got TA, which would be a phono input, long wave, medium wave, and UKW, which is FM. More tone controls over on the right, and up here we've got Sendereinstellung, the tuning knob, and over on the right hand side then the tuning indicator, which is one of the valves involved in this. I think it's an EM84, which is a little green indicator, and then I've removed from the cabinet separately the tone controls, which are still attached to the chassis. And here we have the 3 tone controls: Sprach for speech, Wunschlang, wonderful sound I think, and music. And having a look inside then, the actual component section over here on the left hand side, we've got the mains transformer, the audio output transformer, and tucked in at the back there the valves. The first one there is the sound output, an EL84, and I can see that that's been replaced at some stage with a Mullard valve, which wouldn't have been one of the originals. Then we have a discriminator or detector valve, an EABC 80 I think, or 89 maybe. And then one of the original valves, that's a Siemens valve, which is an EF89. And then around the back here we have the first stage valve, which is an ECH81. And then in this metal container we've got the separate FM tuner, which contains a valve, an ECC85. And you can see here hanging on the front here the original little light bulb for lighting up the panel on the front, which is severely blackened at this stage, so that's a replacement for sure. And then over on the right hand side, the ferrite rod for long wave and medium wave. And then you can see kind of a heavy metal flywheel, which allows you to tune smoothly up and down the waveband as you turn the tuning knob. Now the dial cord seems to be intact at this stage because the needle is moving up and down the scale, so hopefully that won't be a problem either. The chassis itself is, as you can see, quite rusty and dusty. So next thing is the big cleanup before we start investigating the workings of the radio itself. In the meantime, I've made a wooden frame to hold the chassis in place. This means I can spin it around at different angles without doing any major damage to the chassis, because it is pretty fragile at this stage. However, it does mean that I can have a look underneath and see what needs to be done. And the first thing I've noticed, which is going to be a major problem, is that some of the wafers that switch the various wavebands in and out have actually dislodged themselves from the top of the switch unit. This is the underside of the switch unit here. So there's one there, which I think is the medium wave switch section. And there's another one further in underneath over here, which is part of the on-off switch. And while neither of those have many contacts on them and may not affect the overall operation of the set, it would be nice to get it working properly, which means, unfortunately, removing this whole switch section and all the wiring involved that goes into this section from the rest to allow it to swing down and let me fix the wafers back in place. So that could be a major problem. After that, I can see several capacitors that will need to be addressed. There's one, for instance, a paper capacitor. There's 2 more there. And in sets like these, which at this stage are 60 years old, these capacitors will most likely be leaky. However, one very obvious capacitor that is in trouble is the HT capacitor here, which is 2 sections of 50 microfarads each in the can. And you can see here where it's actually leaking goo out through the outside. So that's definitely going to need to be replaced. But before I do that, I'll just disconnect the leads on the electrolytic capacitor, this capacitor here, and we'll take a measurement and see how bad they really are. I've disconnected the wires to the electrolytic capacitor that was showing signs of wear and tear and leakage, and connected it up to a component tester. And if we run that component tester, you will see what the problem here is. So the capacitor, the first stage of the capacitor has changed from a 50 microfarad up to 68. The ESR is pretty low, so that's not too bad. But let's change the connection to the second stage capacitor. So we put that onto that and connect the other side to earth and do a similar test. And up comes no ESR reading at all. However, the capacitance has changed way down to virtually nothing, 26 nanofarads instead of 50 microfarads. So that's got to go. One way or the other, we'll either replace it with modern capacitors, or preferably it would be nice to be able to retain the can and stuff it with 2 new capacitors. While waiting for the capacitors to arrive in the post, I decided to tackle the cabinet. And as you can see from the shot here, the top of the cabinet is particularly grimy, or was particularly grimy, with ring marks on it, discoloration, and on closer inspection there was little bits missing out of the side and front edge. So that needed to be tackled. After that, the front grille was inspected. This is the speaker grille, and the cloth on it was certainly not salvageable, so I decided that had to go and replace it with something better. And on close inspection you can see the decals that were fitted to this grille were particularly grimy, only to be expected on a radio of this age. You're talking about 60 years nearly. So they had to be taken off extremely carefully because they're very fragile, and cleaned up, first of all using Brasso to bring them back to their shiny former selves, and then protected with a layer of lacquer. Well, here's the work on the cabinet so far. I started off by stripping off the original lacquer and staining on the cabinet itself using paint stripper right down to the bare wood, and recoated it initially with brushed on varnish of a silk finish, but when that showed up the brush strokes, it didn't look so good in the light, so I ended up spraying it with a matte varnish, which gave a very pleasing effect. Now, while the top of the cabinet looks a little bit orangey, it's to do with the internal light here. In actual fact, it's quite a nice mid-brown. So as you can see, I've also replaced the speaker cloth with some period piece to keep the look of the cabinet authentic, or as authentic as possible. And I've cleaned up a lot of the front, the trims on the front especially. This one was particularly difficult because it was actually broken, so I had to very carefully glue it together and clean it up and put a protective coating of varnish on it. Likewise with the decals on the front here, these were particularly dirty and they came up looking pretty good and acceptable. So that's as it is at the moment. As you can see, there's no speaker inside, which is the next thing to fit. But before I do that, I must refit the aerial, the FM aerial, which is an internal fixture and consists of foil interior lining of the cabinet connected to the wires that get plugged into the back of the chassis. So, onwards and upwards. I've now removed the HT capacitor from the chassis and disassembled it, taken out the guts of it. It's a bit messy, as you can see, but what I propose to do is to get 2 brand new capacitors and insert them neatly into the can and restore the top and try and tie up the top edge there, and it'll look just like new. The HT capacitors finally arrived. Here they are, 2 47 microfarad 450 volt models, and I've configured them ready to be stuffed into the original container. And here's the finished article ready to go back into the chassis. Now, of course, you don't have to do this, but by fitting the capacitors into the original case, it keeps the radio more authentic than it otherwise would be. The next part of the job was to attack the chassis, and having switched on the radio after replacing the HT cap here, it turned out that there was some sound coming through medium wave, which was encouraging. However, it was very crackly, and in selecting the switches, the noise came and went and the sound came and went, so immediately the radio was switched off, and the main job of replacing the capacitors started. So you can probably see here some of the capacitors that have been replaced already. These are capacitors on the PCB, some electrolytic, some ceramic, and over here, here's a few more that were found to be absolutely rotten. And here's one that hasn't been replaced yet, and you can probably see how grotty it is. It's a paper capacitor, and that will need to be replaced as well. However, with the knowledge that some of the wafers were broken in the switch panel, it required that the whole switch panel had to be removed, and this was a horrific job because dozens of wires had to be disconnected from the switch panel, and even all the wires from the PCB had to be removed as well, because this had to be moved sideways to allow the switch panel, which sits here, to be removed sideways and out. So all these connections were taken a note of here, as you can see, many more. And here we have the switch panel, which eventually came out. And you can see here some of the wafers that we saw earlier that have actually bits broken out of them and were just floating around inside the unit here. So two of the wafers are broken. The one that accompanies the off button, and this explained the reason why the button was lopped sideways, because there was nothing holding it vertical. So that's this particular one here, and you can see the corner broken out of it here where it just wasn't making any contact at all and it had flown out the back. The other one is the medium wave one here, which again was broken, and while there's only one contact in it, here it is here, and again the front part is broken off it, so it was just floating out the back. So after many hours of messing about, I managed to get the switch unit out. And the next job is to try and remake these wafers in order that they support the actuator that pushes them back and forwards. But they'll have to be rebuilt, perhaps with some epoxy resin to make up the missing bits here. So that's going to be interesting. So let's see what happens. I've reformed the broken parts of the sliders from the switch panel with epoxy resin as stated, and left them overnight to dry and harden. So hopefully they'll be in a better condition and will be able to withstand the rigors of the switches going on and off. At the same time, I've cleaned the contacts that slide up and down within these switches, and also the receptors in the switch unit itself. So fingers crossed that this is going to work. The wafers have been placed back into the switch unit, and here we go. Pick up, long wave, medium wave, FM, switch off. Seems to be working. I suppose only time will tell whether the resin that I've used for the wafer repair is going to work, but I leave it for the next day or two to allow it to harden before I test it any further. The switch panel is back in the chassis now, with all the myriad of wires associated with it that had to be reconnected. And of course, when it went back in, everything stopped working, because one of the connections I'd taken note of prior to removing the switch panel itself was actually incorrect, and I discovered that the HT was actually connected to the pickup socket, so not good. However, I found it fairly easily, and when it was reconnected correctly, things sprang into life. However, in an earlier stage of testing the radio, the actual on-off switch, which is operated by one of the piano key buttons here, and it moves an actuator in the form of a metal fork forwards and backwards, and actuates this tiny little switch, little toggle switch with a tiny little metal piece sticking out. Now there it goes again, broken. So I had to use a new type of toggle switch, a standard type of toggle switch. However, the toggle itself was far too big and thick, so I had to hacksaw it down and file it into a blade shape similar to the original one. And as you can see, it's actually filled with white graphite grease to make it move smoothly. So that worked out okay, and the switch panel is now working perfectly. With the switch panel back in, I've replaced the glass panel, the control knobs and the fascia escutcheons along the front edge, and cleaned everything up, so it's beginning to look pretty good. I also repainted the back panel behind the glass, which was spotted with rust and generally manky. So hopefully when the radio goes back into the cabinet with the light bulb illuminating the dial glass, it'll look pretty clean looking. And here we go. And I believe in love, but what else can I do? It's beginning to sound pretty good. I'm still waiting for 3 capacitors here to arrive to replace the faulty ones that I've taken out, and you can see the rest of the capacitors that have been replaced, and a sorry sight they are too. Every single one of them measured incorrectly, either leaky or way out of tolerance. So I'm glad I went through the capacitors as is usual in radio sets of this vintage. They really do need to be replaced, particularly the paper ones. I'm still waiting for the final 3 capacitors, that's this, and this, to arrive so I can finish off the tone section, but they don't materially affect the sound coming out of the loudspeaker in terms of audio quality, even though you can't adjust all the tone controls. So in the meantime, it's time to do a bit of alignment. And to do that, we feed a modulated signal into the grid of the first AM valve over here, AM being medium wave and long wave, and it feeds through this transformer, this valve, this transformer, this valve, and eventually into the audio stages and out to the speaker. So to do that, I'm using my iPad with an app that generates an audio signal, in this case a sine wave at 500 Hertz, and feeds it into an RF generator here, which is set up for a carrier frequency of 460 kilohertz, that being the correct one for this particular radio. So in it goes here, and we align it as we go along. And to do that, while you could do it audibly, it's not particularly good because it depends how good your hearing is. To do it more accurately, what you do is you measure the automatic gain control voltage coming out of the anode of this valve here, which comes down here into a network of resistors and gets fed back into the earlier stages. And according to the strength of the signal, as the signal gets stronger, the AGC negative voltage gets stronger as well. So all we do is we put the avometer onto that point there and measure a negative voltage coming out. So the stronger the signal, the more the negative voltage. And with that in mind, we adjust these coils here, 1, 2, and 3 and 4, to get the maximum signal here. And where these are located in the radio is down here. There's one there. There's another one there. And the corresponding ones on the other side of the coil, at the top, here and here. So having done that, the sensitivity of the medium and long wave has come up greatly. So there's been a good improvement, which would suggest that they've been misaligned at some time in the past. The next thing to do then is to align the RF section. And to do that, we similarly get our signal here, but this time it's a signal corresponding to the extreme dial settings on the radio to coincide with what it says on the dial. And we adjust these little trimmers, various ones here in particular, and some more over here for both medium wave and long wave. And in that way the dial reflects exactly the frequency of the signal coming in, so that the stations are all in their correct position. And again, that came up quite well. However, instead of feeding the signal into the grid for this purpose, we now feed it in via this loosely coupled coil and put it near the ferrite rod aerial in the radio, which is this guy here. And again, you get a tone coming through and you adjust it for the maximum signal on the meter. So that's done now, and I could do the same thing for the FM section, but in actual fact the FM section is working brilliantly, so I've decided to leave well enough alone. This is the tweeter loudspeaker in this particular Grundig radio, and it was typical of the type of tweeters put into radios of that era, because unlike a normal loudspeaker like this one, which we're all familiar with, that has a moving cone that goes in and out, the tweeter in this is what's called an electrostatic loudspeaker. And instead of having a cone that goes in and out, it has a flat mylar film inside here and a membrane on the other side. And on the mylar film there is a conductive surface which is connected to one of these wires, and the membrane on the other side of the non-conductive side is connected to the other side. And it's fed directly from the output of the sound output valve here up to this point here, but it sits on top of a very high voltage 170 volts DC, which comes from the HT signal here, and that electrostatic voltage with the audio signal superimposed on top of it causes the membrane to vibrate. But it's only good for very, very high frequencies, and that's why it was generally used for tweeters in radios from this era. Now, it wasn't working very well. You could hardly hear any sound coming out of it at all, so I decided to take it apart. And while I couldn't see anything materially wrong with it, and the story is that a lot of these used to have foam keeping the mylar membrane in place, but this must have been a slightly different model. It didn't have that foam in it, and the foam normally deteriorated. In this case, it seemed to be okay. I couldn't understand why it wasn't working, so I just put it back together again and tried it out again, and hey presto, it sprang into life. So there must have been a poor connection between the wires that go into it and the connection to the mylar film and the other film on the other side of the medium that's inside there. So that's going to be popped back in, and we're nearly at the end of this project. So hopefully in a short while, when I get the capacitors, pop them in, stick the chassis back into the cabinet, and we'll have a radio working again. Well, the final 3 capacitors for the tone shaping circuit came in today, and they've now been fitted into the PCB on this radio, which turns out from the circuit diagram to actually be approximately 1958, so I was a couple of years out in the dating earlier on. So the radio is finally finished now, so let's have a listen to the tone. So it's sounding really good, so I'm really happy with the outcome of this project. So now it's time to dismantle it from the frame and pop it back into the cabinet. Here we are at the end of the restoration, and I have to say it looks pretty good. The chassis has gone back in and it's all been bolted together again. So let's have a closer look at it to see how it turned out. The control knobs came up really nice once they were cleaned, and these are the bass tone controls, which when you adjust them, a little orange window lights moves up and down behind. Push buttons came up nice and clean. The dial's looking good. I'm particularly pleased with the speaker cloth, the new speaker cloth, which really enhanced it. And these further tone controls came up pretty well, and the little brass decal above it as well. And as you can see, the magic eye is working pretty well as we adjust it. It tunes in. And the Grundig logo itself cleaned up, having been repaired. And the cabinet came up quite nicely as well. So let's have a listen to it.
A lot of time.
Polytula her bunnig in ID.
Head-to-head thing, one asks one thing, the other just responds with retreating place basically over.
So as you can hear, it sounds pretty good. So if you've got this far in the video, thanks very much for watching. If you haven't and you've fallen asleep, and I can't blame you, nighty night.